These are notes on Taylor and Maclaurin polynomials. They're kind of the same thing. A Maclaurin polynomial is one special case of a Taylor polynomial. So if we have a function and we know its function value as well as all the derivative values at one point, we can represent that function by a polynomial. It would be an infinite polynomial, so you're not going to be able to write the entire polynomial, but we're going to write part of the polynomial. And the more and more terms that you have, the better the representation is of the given function. And the way the Taylor polynomial works, the polynomial is equal to, it's the function value at the x value, so c is my x value, plus the derivative at the function value times x minus c. So this is the constant part, this is the x to the first part, plus the second derivative of the function at c divided by 2 factorial times x minus c squared, plus the third derivative divided by 3 factorial times x minus c cubed, and so on, plus the fourth derivative divided by 4 factorial times x minus c to the fourth, the fifth derivative at c divided by 5 factorial times x minus c to the fourth. Notice this does go 4 factorial with the fourth term. The cubic term is divided by 3 factorial. Second term, the quadratic term, divided by 2 factorial. You could divide by 1 factorial here. 1 factorial is 1. You could divide by 0 factorial here. That is also 1. We just usually don't write those parts. Where it's centered, if it is centered at 0, it is called a Maclaurin polynomial. If it is centered anywhere else, it's a Taylor polynomial. Really, this is a Taylor polynomial too. It's just a special type of Taylor polynomial. So if you ever see Maclaurin polynomial, just know that it's centered at 0. So example 1 tells us f of 3 is 4, f prime of 3 is 5, f double prime of 3 is 1/4. The third derivative of f at 3 is 2/3. We are asked to write the first 4 non-zero terms of the Taylor series centered at x equals 3. So our polynomial is equal to the function value, so 4, plus the derivative times x minus c, plus the second derivative divided by 2 factorial times x minus c squared, plus the third derivative divided by 3 factorial times x minus c cubed. And then just clean it up. Our polynomial is 4 plus 5 times x minus 3 plus 1/8 x minus 3 squared. That's 6, so we have 2 over 18, 1/9 times x minus 3 cubed. This one asks us to find the second degree Taylor or Maclaurin polynomial for the given function. So the fact that it's a Maclaurin polynomial tells us that our center is at 0. So we need to know what is f of 0, f of 1. And what's the second degree? So we have 2 terms. Second degree would, I'm sorry, this is f prime of 0. So we need the second derivative, f double prime of 0. So f of 0, if I plug in 0 here, I just get 1 divided by 1. We need to find the first and the second derivative. To do that, I would probably rewrite this as x plus 1 to the negative 1/2. And then use the chain rule. So there's our first derivative and our second derivative. Plug in 0 into each of those. 1 to any power is just 1, so it's negative 1/2. This one's 3/4. So our second degree polynomial, a lot of times you'll see it written p sub 2 to show that it's a second degree polynomial, is equal to 1 minus 1/2 times x minus 0 plus 3/4 divided by 2 times x minus 0 squared. So that 3/8 came from this 3/4 divided by 2 factorial. Example 3. Ask for the first 4 terms in the Taylor series centered at x minus 1. So we are going to need f of 1, f prime of 1, f double prime of 1, and the third derivative at 1. Notice that's going to give me 1, 2, 3, 4 terms. To find the derivative of this, we need to use the product rule. So derivative of the first one times the second one plus the first one, or derivative of the first one. I'm all over the place today. All right, derivative of the first one is 1 times e to the x plus the first one, x minus 1, times the derivative of the second one, which is e to the x. We're going to need the second derivative. So e to the x plus the derivative of this. Well, the derivative of this, same thing as this, is this guy here, right? So we have another e to the x plus x minus 1, e to the x. Our third derivative would be 2e to the x plus the derivative of this. Well, that's the same thing as this. So the derivative of that is this guy here again, e to the x plus x minus 1, e to the x. So the function value at 1 is 0. The derivative at 1, if I plug in 1 here, is e to the first. Second derivative, if I plug in 1, this is 0, so it's 2e to the first. The third derivative, if I plug in 1, is 3e to the first. This isn't real clear. It asks for the first 4 terms. Usually it'll say the first 4 non-zero terms, so this term would not count. If it didn't count in this case, the fourth derivative at 1 would be 4e if we did it again. So our Taylor polynomial is equal to the first term, 0, plus the derivative times x minus 1, plus the second derivative divided by 2 factorial times x minus 1 squared, plus the third derivative divided by 3 factorial, 6, times x minus 1 cubed, plus the fourth derivative divided by 4 factorial, 24, times x minus 1 to the fourth. So final answer, our Taylor polynomial is e times x minus 1 plus e times x minus 1 squared plus 1/2 e times x minus 1 cubed plus 1/6 e times x minus 1 to the fourth. This one asks for the coefficient for the term containing the x minus 3 squared, centered at x equals 3. So the squared term is going to have a second derivative in it, centered at 3, dividing by 2 factorial. So we need the second derivative. Our second derivative is negative 24x plus 6. At 3 gives me negative 72 plus 6. Negative 66 divided by 2, our coefficient is negative 33. This one's a little bit different. It says the nth derivative is given by this formula. So the nth derivative of g at x equals 0 is given by this formula. So if I wanted the second derivative, I'd plug in 2. If I wanted the third derivative, I'd plug in 3. If I wanted the 12th derivative, I'd plug in 12. It wants the coefficient of the x squared term in the Maclaurin series. So Maclaurin series, so we are looking for the second derivative at 0, second derivative because we're looking for the x squared term, divided by 2 factorial. So plug in 0 gives me, I'm not plug in 0, plug in 2 because it is the second derivative that I'm looking for. It gives me square root of 9 over 8. So the derivative, the second derivative is 3/8, and then divided by 2 factorial. 3 over 16 is the coefficient. We've done one like that. So what I want you to do is to try to find the Taylor polynomial for each of these 4 polynomials, or 4 functions. So find the Taylor polynomial for e to the x, cosine x, sine x, and ln of x. Let's go centered at x equals 0. For the first 3. This one, let's center at x equals 1. And let's go the first 4 terms. First 4 non-zero terms. Bring those up to class when you have finished, not when you have finished, but when it's time to meet, and we'll check those.